This video is for the logs I section of the logarithms module, and this section has been split into two parts. This is part 1. In this video we're looking at applications of logs, so basically problem solving. This first question says the Richter scale defines the magnitude or size R of earthquakes by comparing the intensity I of an earthquake to the minimum intensity I's base 0 using R equals log of I over I base 0. What is the magnitude of an earthquake with an intensity of 2 times 10 to the 8 times of I base 0? So, let's start with our formula. R equals log of I over I base 0. Okay, the question says that what is the magnitude of an earthquake with an intensity 2 times 10 to the 8 times of I0. So that means that I equals 2 times 10 to the 8 of I0. So we plug that in. R equals log 2 times 10 to the 8 I0. So now let's put the 0 up there. All over I0. Okay, so from there you can see that these I0s can cancel, I base 0, sorry, so that disappears. So now I have that equal to log of 2 times 10 to the 8. You can just plug that straight into your calculator, or you can think, well, I can split that up as log of 2 plus log of 10 to the 8. Okay, these will cancel because that's a base 10. So I'm left with log of 2 plus 8. Plug that into your calculator and you get approximately 8.3. Okay, finish with a therefore because it's a therefore question. Therefore, earthquake has a magnitude of approximately 8.3 on the Richter scale. Okay, now let's look at the next one. In the 1989 Newcastle earthquake had a magnitude of 5.6 on the Richter scale. How many times I base 0 was this earthquake? So in this case it's telling me that R equals 5.6. So in my formula, which is R equals log I over I base 0, I have 5.6 equals log of I over I base 0. From there I can rearrange my log into an exponential because that's a base 10. So I end up with 10 to the power of 5.6 equals I over I base 0. Okay, so from there it's asking me what I is in terms of I0. So I want to get this I on its own, so I multiply both sides by I base 0. And I end up with 10 to the power of 5.6 I base 0 equals I. Okay, now if you work out what 10 to the 5.6 is on the calculator, so just plug 10 to the power of 5.6 and you get if we're going to do it in scientific notation, you get I is approximately 3.98 times 10 to the 5 I0. Okay, so therefore Newcastle earthquake, sorry about that, Newcastle earthquake was approximately 3.98 times 10 to the 5 I base 0. Okay? You may want to now pause this video and try and do that question yourself on your own. Let's look at another one. Students in a math class take a final test and then are tested with equivalent exams monthly after that. The average test result T after n months was found to be given by. What was the initial class average? Well, the initial class average is going to be when n equals 0, because time is 0, no months have passed. So we end up with t, write our formula, 74.5 minus 22 log n plus 1, and now I plug in 0, so 74.5 minus 22 log 0 plus 1 is 1. Okay, log of 1, which is here, is equal to 0. So now I have 74.5 minus 22 times 0, which is simply 74.5. Okay, so therefore the original class average was 74.5 marks. Next one, what was the average after 3 months? When we go back to our question, it says n is in months. Okay, so in this case, if we're looking at 3 months, it means n is 3. So it's exactly the same question as before. So I've got, write out my formula, plug in 3, which is 74.5 minus 22 log of 4. Now from there I can go straight to my calculator, okay, and I end up with approximately 74.5, 22 log of 4 is 13.2 approximately, so my answer is approximately 61.3. So therefore, and I'm not going to write this out in full because I'm trying to save time, so class average after 3 months would be expected to be, remember we're using a model, so it may not be, approximately 61.3 marks. Okay, next one, after how many months would it be expected that the average mark would be less than 50? Okay, so in this case what we need to know is when will it be 50? So when will t be 50? And we don't know what n would be. So our formula, t equals 74.5 minus 22 log n plus 1. So I've got 50 equals 74.5 minus 22 log of n plus 1. I need to take 74.5 from both sides. Okay, so 50 takes 74.5 is negative 24.5. I'll write what I've done. Just taken that 74.5 from both sides, and I get negative 22 log of n plus 1. Okay, rearrange that because I need to get rid of that minus 22, so I divide both sides by negative 22. So I end up with negative divided by negative is a positive, so 24.5 over 22 is log of n plus 1. Okay, so all I've done there is divide both sides by negative 22. From there, leave that as a fraction. Don't approximate it because it means your answer ends up super approximated. Okay, our base here is 10, so let's just rearrange it to be an exponential. So I get 10 to the power of 24.5 over 22 equals n plus 1. Take 1 from both sides. So now I've got 10 to the 24.5 over 22, take 1 equals n. Plug that into the calculator and you get n is approximately 12. Okay, I can't fit my therefore statement in, but the therefore statement would be the average mark would be expected to drop below 50 after 12 months. Okay. Let's look at another question. The pH scale measures the acidity of solutions. Now acidity ranges between 0 and 14. Values of less than 7 are acidic and values above 7 are alkaline. The pH value is defined by pH equals negative log of H plus, where H plus is a concentration of hydrogen ions in moles per litre. So there's our formula in there. Okay, find the concentration of hydrogen ions in saliva that has a pH value of 7.2. Now, remembering that the concentration is the pH. That sounds confusing, but don't get too caught up in it, okay? If you look at that, the formula is pH equals a negative log of H superscript plus, okay? It's saying, go back, find the concentration of hydrogen ions. So you don't know what H plus is. That's the concentration of hydrogen ions, but you do know that the pH is 7.2. So write the information down from the question, then come back to your formula and plug it in. So 7.2 equals negative log of H plus, which we don't know. From there, this is base 10, so we can rearrange it to be an exponential. 10 to the power of 7.2. And wait 1 second, I go back a step. So I just noticed when I did that I have this minus out the front. So I'm going to take him over to there. So now I'm going to have negative 7.2 equals log H plus. Now I'll rearrange it, remembering this is base 10. So 10 to the negative 7.2 equals my concentration of hydrogen ions. Plug that in your calculator and you get 6.31 times 10 to the negative 8. Finish with, therefore, the concentration of hydrogen ions, and I'm not going to write this because it's in the book so you can look at it, but the therefore statement will be, therefore the concentration of hydrogen ions in saliva is approximately 6.31 times 10 to the negative 8, and it's moles per litre. Okay, go back to your question. It said moles per litre. Okay, so a very confusing question if you break it down, isn't that bad? Let's look at the examples for the section logs I2. It's got, while cooling in a room at 20 degrees Celsius, the temperature T of a cup of tea depends on the number of minutes T it has been cooling according to, and again it gives me my formula. Okay, what is the initial temperature of the tea? Okay, so again, it says while cooling a room at 20 degrees Celsius, the temperature T of a cup of tea depends on the number of minutes. So little t equals time in minutes. And capital T equals your temperature. Okay, of the tea. So what is your initial temperature of the tea? Well, that's going to be when T is equal to 0, because no time has passed. So write my formula, T minus 20 equals 65 times 0.96 to the T. T take 20 equals 65 times 0.96 to the 0. Now anything to the power of 0 is 1. So now I have T take 20 equals 65. So I add 20 to both sides and I end up with T equals 85. Okay, so therefore T was initially 85, and what's units? Degrees Celsius. Okay, next bit, how long will it take for the tea to reach a drinkable temperature of 50 degrees Celsius? So it's telling me capital T is 50 degrees Celsius, and I want to know what little t is. So T take 20 equals 65 times 0.96 to the T. Plug in the 50. 50 take 20 equals 65 times 0.96 to the T. 30 equals 65 times 0.96 to the T. This is a time, so to get rid of that I need to divide both sides by 65. So now I have 30 over 65 equals 0.96 to the T. Again, I'm not going to work out what that 30 divided by 65 is, because then I'm approximating twice. I rewrite this now as a logarithm and I end up with T equals log to the base 0.96 of 30 over 65. Okay, to work that out, I need to convert it into a log of base 10 or a natural log. So I'm going to have log of 30 over 65 all over log of 0.96 plug that into your calculator and you get approximately 18.9. I can't fit my therefore statement in, but I'll say therefore it will take approximately 19 minutes for the tea to cool to 50 degrees Celsius. And it's in minutes because that's given in your question. Okay? Always have a therefore statement when you have a worded question. Last example of this section in this video, the accumulated amount A that a principal P will be worth after n years if invested at an interest rate of R is given by. This is actually a compound interest formula for any student who moves on to finance. When the investment is compounded annually, so it's compounded annually, how many years would it take to double an investment at 6% per annum compounded annually? Okay. So my formula is A equals P bracket 1 plus R to the power of n. Okay. From there, I want my investment to double. So I want A to equal 2P because P is my initial investment. And I know that my R is 6%, which is 0.06. Okay, so plug that in. 2P equals P 1 plus 0.06 to the n. I can divide both sides by P and you'll see that those P's will cancel. So I now have 2 equals 1 plus 0.06 is 1.06 all to the power of n. Rearrange that into a log and I have log of 1.06 2 equals n. Okay. From there, let's rearrange this so I can plug into my calculator. So that's going to be log base 2 over log, sorry, not log base 2, log base 10 of 2 over log base 10 of 1.06 equals n. Plug that into your calculator and you get approximately 11.9. So your therefore statement would be it would take approximately 11.9 years. Now you could work out 0.9 years, 0.9 times by 12, it's approximately 11 months, so you've got 11 years, 11 months for investment to double. Okay. Oh, there is one more. I thought that was the last one. The quantity of items Q of a product demanded is dependent on the price P of the item according to P equals 15 minus 0.02Q. What quantity of product will be required when the price is $3.80? Okay, so let's start with our formula. P equals 15, 1 takes 0.02Q. Let's go back and see what we've got. It says what quantity of a product will be required when the price is $3.80. So that means P equals 3.8. So come back, 3.8 equals 15, 1 minus 0.02, Q. From there, let's change it to a log. Log base 15 of 3.8 is 1 minus 0.02, Q. Rearrange this to be a log we can work out on a calculator. So I'm just doing them both logs of base 10. That's going to be 1 minus 0.02Q. From there, I can get Q on its, I need to get Q on its own. So what I'm going to do, because that's a minus there, I'm going to take that over to that side and that over to that side. So I end up with 0.02Q equals 1 take log of 3.8 over log of 15. Note, I'm not working anything out because I don't want to approximate too much. I need to get rid of this 0.02, so I have to divide. One thing that's different in TM Plus, we don't want you to keep approximating all the time. You want to leave it till the end. When you plug that in your calculator, you get approximately 25.4. So therefore, the demand would be approximately 25 items at $3.80. So what do you do now? Well, you need to do lots and lots of practice, and there are 2 exercises for this first part of the logs I module, and that's logs I1 and logs I2. There are a lot of word problems in there, so have a go again, watch the video again if you need to.